In this lecture, we are going to talk about some pop neuroscience, some neuromyths that you've probably heard, what part of them is true and what part of them is not true. So first, neuromyth. This is one of the ones that we hear most often, the whole left brain, right brain debate. And how this one goes is that left brain people are analytical and right brained people are artistic, and that you can tell this based on how long one finger is or what color you see in something. So this is pretty much bunk. What is true? There is a left side of the brain and a right side of the brain. That part is true. Some functions reside more on one side of the brain. For example, the left motor cortex controls movement in the right arm and the right leg. What's not true about this is that there are very few things that are this clearly defined, with functions only residing on one hemisphere or another. And also, this really has no bearing on personality. Next neuromyth. This is one of the most pervasive, the whole you only use 10% of your brain myth. And the way this one goes is that humans use only 10 to 20% of their brains, and they could do amazing things if they could use 100%. And there are lots of TV shows and movies that have portrayed what exciting things might happen if humans were able to use all 100% of their brain capacity. So these are fun, but what part of it is true? Well, it is true that the brain is not all active all at once. That's about it, though. What's not true? Functional neuroimaging shows that well over 10% of the brain is active during a large number of tasks. And also, there are some regions that downregulate others, meaning some brain regions, when they're active, they're telling other brain regions to not be active. So if somehow you did achieve 100% activity, it would be very confusing. Next one is multiple personality disorder. This one has so many portrayals in the media. It's an interesting one to try to portray, however poorly they do portray it. In movies and in TV shows, this is a common one, both across comedy and across horror shows. So what's the truth here? The recognized name of what people have called multiple personality disorder in the past is dissociative identity disorder, or DID. DID is not the same as schizophrenia or bipolar disorder. So if somebody says, goodness, I'm being so schizophrenic right now, I can't make a decision on something. This is not at all what schizophrenia is. The whole having trouble making decisions, being two different personalities, that's completely different in schizophrenia. And bipolar disorder is also completely different. Bipolar disorder is swinging between two mood states, not swinging between different identities. People with DID often in the movies are portrayed as violent. They are not violent by nature. They are not by nature any more violent than the rest of humanity is. DID can be a reaction to extreme trauma, often in childhood. So this can be a protective mechanism that some people turn to if they have faced extreme trauma. This can be a way of compartmentalizing it and not having to deal with the full weight of the trauma that they've encountered. Next, neuromyth, or neurofacts that people like to play with in creative ways. The male brain versus the female brain, whether it's men are from Mars and women are from Venus, men are like waffles, women are like spaghetti, whatever that means. Or this lovely graphic here about different brain regions being responsible for different functions in males and females. These are, for the most part, bunk. So what part of this is true? Well, yes, there are significant differences in males and females in brain structure and function across the lifespan. We can see this in this these trajectories here that show how the volume of different brain regions change over the lifespan in males and females separated, where males are this blue line and females are this pink orange line. So you can see that they generally have the same shape over the lifespan, but yes, there are some differences. These lines are not on top of each other the whole time. This other study over here looked at structural connectivity in the brain. So looking at the connections that connect to different brain regions, the tracks that connect different brain regions and support these different brain regions working together. And this study found that males tended to have stronger connections within a hemisphere, so within the left hemisphere or within the right hemisphere, running anterior posterior, so from the front to the back within hemisphere. Whereas females had stronger connections than males in some of these tracts that run between the left and the right hemisphere. So there are some significant differences, and these probably do play some role in functional differences, and might be related to hormones, a large number of things. But how significant are these significant differences, or how pronounced are these differences? Is there truly a male brain and a female brain? Are they so distinct that you could look at a scan and say, oh, well, I see the volume of the hippocampus is blank. Therefore, this must be a female brain. Or, well, this scan here has a cerebellar volume of something else, so it must be a male brain. Is that really how it is, where it's so distinct? No, not at all. There are some significant differences, of course. There are patterns that are different between males and females, but there's also a lot of overlap. So just in this toy example, if you had some value in the male brain that tended to be more on the whole on the left, whereas in the female brain, this value tended to be more on the right. Yes, any given female might be more to the right, and any given male might be more to the left, but there's also this incredible amount of overlap here in the middle. And this is just a toy diagram, but it's what I'm trying to illustrate is the fact that these are not two distinct things. There's not a male brain and a female brain. There's a lot of variation in humans, and there are some patterns that tend to occur based on sex, but they are not so distinct. They definitely overlap in a lot of ways. Next one is amnesia, another one that movies love to portray because it can do a lot of interesting things with this one. So some examples here, and now some facts about amnesia. So there's lots of different types of amnesia. We can talk about retrograde amnesia, which is where people forget past events. This can occur after a traumatic brain injury. We can talk about post-traumatic amnesia, or PTA, after a traumatic brain injury. And this can last for minutes, hours, days, or weeks if someone has a very severe injury. And the other area where we often think about retrograde amnesia is dementias like Alzheimer's disease, where difficulties with memory are a hallmark of these disorders. Anterograde amnesia is the inability to make new memories. So, for example, Memento or the 51st States. So one example here is to think about from the past is patient HM. Patient HM had severe epilepsy, and so he had a bilateral medial temporal lobe resection, meaning they removed his hippocampus and amygdala to control his epilepsy. And while this did control his epilepsy, it left him unable to form new memories or remember anything from the past decade. So this is an example of both retrograde amnesia and anterograde amnesia, and it told us a lot about what parts of the brain are important for memory. Drug-induced amnesia. Excessive alcohol can inhibit the memory-making processes in the brain and thus cause a blackout. So this is why after, for example, in The Hangover, after a night of heavy drinking, the individuals were unable to remember what they had done. Also, Rohypnol, roofies, or the date rape drug causes anterograde amnesia for a few hours after it's been given to an individual. And lastly, dissociative fugue state or dissociative amnesia. This is where an individual has lost memory about their identity. So for example, the born identity or Anastasia. This is often a response to severe trauma and can be part of, though it's not always part of, dissociative identity disorder. Repressed memories and recovered memories. So is it possible to repress a memory due to childhood trauma and then unlock it later in life? Are these repressed memories genuine or are they made up? Repressed memories were central to Freud's theories back in the 1800s. He proposed that some memories were so traumatic that they were pushed down into the subconscious, where they influence behavior and they influence personality, but they were not at the level of consciousness such that someone remembered that they had actually happened. This has been a debated topic in the field of psychology for some time. The debate really came to a head in the 1990s when there was a big hubbub about a bunch of psychologists who were proposing that they could unlock memories in patients. And there were a lot of cases of recovering memories of child sexual abuse that some of which were later found to not be genuine. So, what is true about memories? Memory is malleable, meaning it is susceptible to influence. It's not something where, like a computer, it is recorded and there it is static in your brain and it doesn't change. You can think of many examples of this where maybe you have a fuzzy memory from your childhood, but you've heard stories that your parents have told about that event, and those over time, those become conflated with your memories. And then it's hard to tell what you actually remembered versus what you have inserted into your memories through that retelling. Memory is when you're trying to assess it, there are a lot of ways a lot of things that can influence how answers are given. So the phrasing of questions can change how people report memories. The context can influence how people report memories. So it's definitely something that is fallible. It is susceptible to change. It's vulnerable to suggestion. But on the flip side, can you truly implant false memories? This is also still debated in the field. To some degree, you can influence memories, you can implant other parts, but the degree to which you can truly implant full false memories into people is debated, and I'm sure differs between individuals in terms of how susceptible they are to this. So that's just a few of the neurofacts that you probably have already heard or will hear out there, and some of the truths and not truths about those. So hopefully this will help you as you go forward and learn more about neurology, neuroscience, neurofacts, and help you assess what's true and what's not true.